Well, good night, GDG. Welcome to Umain again. Um, First, I will start to talk about this night how we can hack some Android applications without using any fancy network resource or any zero-click attack, just using the front door. The end of the talk, you will be able to explore some flaws in some apps using your own device. But just remember, with great powers, great responsibilities. So everything that we show here, that I show here, is with a live device, no record video, no trickies you can do. There's a demo app that I will share in the final slides, in the GitHub, everything, all commands. I will cover 70% of this app. There's more tools, but will require more time, and so it's a more short presentation for this. So, first of all, my name is Jackson Mafra. I'm a mobile engineer here on Umain, more focus on Android. But in the last 2 years, I've been breaking apps and understanding how it, not just understand how it works, but how can I break our app and how I can protect our apps. And I try to break more apps than I was supposed to do. So, and I read some articles. I had some articles on my LinkedIn and my Medium. There's the QR code for you get. I have some fancy demos and some fancy projects on my GitHub that you can reach, download, run, crack, break, and report. Okay, open an issue, everything, it's open. As was talked before, happy Star Wars Day. And this joke is for Star Wars fans. It's exported through for the Android security. Is one of the ways that R2-D2, one of the robot androids, used it to break the Star Wars, the Death Star, and how the rebels extracted the plans and destroyed the Death Star. So no authentication, nothing, just a trick, and they destroy it. So this joke fits well for today's presentation. But before we start to talk breaking stuff, and we need to understand first our scenario. Like Android is present in 7% of world mobile, and so we are run a lot of apps, and run followed by 26 to 28%. I have the links for the sources of the numbers. And so what happened? Most of our data, it's banking, health data, your sports, everything that you are using, identity, payments, they are stored basically in apps. And the security in most of the apps are always an afterthought. And so most of the developers just think about security after you have a breach. And so, oops, I need to fix something. And then you have some problems. So because of these numbers, Android is the most target. If you look in GitHub, there's many ways, is more tools for pen testing on Android. But also there's for iOS. But let's cover. So, as I mentioned, before we go through, we need to understand what we are breaking here, what we are attacking. You need to think in your app, when you are developing, you also have this feeling, okay, how can I break this? How can I break my code? It's more or less how you write some tests. Okay, how I can break this test? So first you need to understand, Android runs over a Linux kernel, and then you have your native app connected to the Java API and the frameworks. Everything is well connected. Everything is supposed to be well secure. But the most of the mistakes happens when the developer forgets some valves, some ticks. And so, okay, this is secure, and this is the hardware abstraction layer is all secure, the native libs, the runtime, the Dalvik, the Android runtime, but sometimes when you try to connect them, you forget some stuff, and then you leave the door open. So, remember, every app, they are living in our own box. You have a sandbox. And for application talk with another application, you have to use Android IPC. That is the bridge that will talk. It's inter-process communication that, okay, I need to expose an activity, a service, a content provider, something to talk with another app. Unless you have some other process that it's covering and connecting this, or you have a root device, but it's for the next slides. But basically, the app B can't talk or can't see the files of the app B or C. They have their own user ID, the application ID, and their place. But APK, it's something that you need to understand. It's just a zip file that you can download from anywhere. So, but we have the bundles now. But a bundle, when you publish a AAB file, it's just a bunch of APK in the end. So I can download. There are many sites that you can just download the APK, the AAB, and extract that APK. And as an attacker, here's where this starts. So, as I mentioned, it's a zip file that I can extract. And my manifest is a blueprint of the application. So, in the manifest, you have your activities, your deep links, your services, content providers, everything that needs to be registered to the system. So, let's, for example, here. I have the APK of this application that I'm running here. Everyone in the background can see, read, fine? Okay. So I have this APK here, and as I mentioned, let's run zip. So I extracted the zip and has the meta info. Let's just back here quickly. So you have the meta info, sign-in certificates, you have native libraries, your resources, images, icons, whatever, strings, layouts. You have your compiler code and the manifest. So as an attacker, I can come here and just cat. It was a lot. Here. So this is the manifest that I extracted. And so I can do this with this application or Instagram, Facebook, Klarna app, any application. You just download the APK and you extract. So here you say, okay, I have all the permissions. So it's one good thing that I will start to thinking to explore. Okay, there's these permissions, there's these activities, there's these services, there's some receivers, and so I can start to list. As I mentioned, it's a blueprint. You start to map what I can try to explore here. So, just take in your mind that take care, don't save anything. I will repeat this a lot during the presentation. Don't save sensitive data in strings. Nothing inside the app. You need a token. You need a GWT or any other key. Save in the backend. And then you make the request. Everything that is saved here will be exposed, can be readable. So we can use a bunch of tools, but the most known here and easier to work, I will cover some of them. That is ADB. It's well known for you, ADB, Android Debug Bridge, that you can list your devices, you can install the APK, you can pull the APKs or files that it's in the device or emulator, and you can run shell commands on the device or emulator. You have the burp suite that is to intercept and manipulate the network traffic. You can use like chars, Proxyman, or any other tool, but burp suite, you have more automation tools and inspections. There's a community version for burp that you can use. Frida, that it's testing automation framework that will hook some process inside the device or in your application. I will show later. So you can inject, and it will manipulate everything that is dynamic in your app. So I can bypass tons of things. Oh, my application have 2FA. Fine. Frida don't care. Everything that you have in logic inside your code, it's Frida just care about what your code do. Oh, I have a feature flag. Fine, I can enable. My application is, I have a freemium and I have a paid version inside the app. I can enable with Frida. There's many scripts for Frida to run and unlock games. So you can use Frida for this. Mobile Security Framework, MobSF, also together with MobSF, inside there's JDX and APK tool that is for automated testing, static analysis and dynamic, and also to revert the code. You do some reverse engineering, and you can extract your code that was compiled. So we'll cover just Frida and ADB and the GDX. MobSF and burp, I can create another talk for the future. But let's see. As I mentioned, inside the APK, you have the compiled code, the DEX files. And inside the DEX files, you have like this. So it's not readable. But with GDX, you can do something like this. I have the same APK here. And so JDEX, you can install using download the package or Brew or many other. You have this also for Linux. And so here I'm extracting the APK. Take some time. Just me. Go. It will tell you, oh, okay, there are some files that I can extract and say, oh, okay, from 5,000 files, I just couldn't extract 67. 67, Jesus Christ. I try to avoid the joke. And so you can do like this. So I reverted the compiled code, and basically you can read. It's not the final code, but it's how the compiler understands. And here are all the functions. And if you are setting some stuff and some values, they are exposed here. So is that why? Take care, because your code can be read. So as an attacker, I can check here if there's some keys, tokens, passwords. So I can look for this. And also in the app, I show this. Okay, if you do a grep here, or I do a grep listing the repo, the extracted files, I can list for secrets, tokens, or whatever. So, again, avoid hard-coded secrets, API keys, or hidden endpoints. Nothing is secure. Always verify, always check what is, because I can have like this. Oh, admin, or some secret, or some token that wasn't supposed to be exposed. Now, the map, because when you open the app and I have everything exposed, is where the things go wrong. So you can check as exported activities, services, receivers, content providers, deep links. I will talk about these guys, deep links, web views, insecurity storage, and SQL injections. So when you open, when you create an application, you have your main activity. The main activity, or whatever is the first name of your splash or whatever, the start activity that you have in your application, by default, it has a property called exported true that you register in the system and say, okay, for this hack demo, this is the activity that is exposed. Or if you have a file preview, or a video, or whatever registered to manipulate some file, you say to the system, okay, when you have this, this is the activity of my application that will handle this file, or you should go. But many developers sometimes forgot, or before Android 8, Android 9, yeah, really, really old, exported was true by default for the activities. And then Google changed it from Android 10 or 11, if I'm not wrong, was set to exported false all other activities. But if you have a legacy app and you just forgot this, you can have many activities that aren't supposed to be shown. So in this case, I will show an example that, okay, I have an activity, a dashboard, that it's supposed to be behind a login flow. And so I have a login flow, you are logged, and you go to that activity. But I looked in the manifest, and I saw, there's exported true here. Let's check what I can do with that. So, and I listed, and so here using ADB, I can say ADB shell, AM start, and I pass the path for the activity that I want to execute. I can do this with any activity. And we'll show if it's exported true, I can list, and okay, here's the activity. And so here, my device, I'm not different, and so I bypass it, because in this activity, there's no verification. So every time that you run, okay, on resume, on pause, it's up to you where you should check. And also using Frida, for example, I can attach, okay, I saw that this activity receives some data and in the intent. And so using Frida, I can manipulate this intent data. And so I can pass anything inside here. So every time you have sensible areas, secret areas, take care of your intent data. Validate everything. It's painful, yes, but it's more painful when you have a branch or someone break your app, or if your app is related to money, healthy, or more sensible data, you need to be extra care. with this. And so here I exposed everything, and maybe I can click and deactivate or activate some areas, some parts of that I wasn't supposed to do. So the same happens with services and broadcasts. So I can just run via ADB, and I launch something that wasn't supposed to be launched outside the app. So just list and then run. Well, other area that is exposed and is really explored for attackers is deep links. What's the purpose of deep link? Okay, you click in that schema, that link, and you go for a specific area of your app. You get a promo code, you have a 2FA, and then you click, you open authenticate, promotion, validate something, get a product, get a deal, or whatever. But also, as the deep link is registered to the system, so you have the schema, the action, and the params. I list it, and so let's test this. And let's suppose that you have a bank app, or you have some points that you can transfer for friends. Attacker, look at this, and I can write an application, and there's tons of these kind of applications, some fancy free games that are in Google Play Store that it's a game. But under the hood, and I had another talk about this that I can share later, that, okay, under the hood, it's a game, but it's getting or sending deep links or monitoring some services from a specific app or many apps. Okay, I open Klarna, I open Swedbank, or I open whatever the app that I'm targeting, and I can monitor if there's some process running. Oh, I will send a push notification with the icon, with everything. Looks like the app. The user click. And I can do like a transfer, because the user will trust is the app. Is the app of the bank. How will I want trust? And it's everything pre-filled. So let's transfer. So here, I run. Okay, you open that app, run this intent, and pass this data. I show, okay, there is transfer, and the amount, and the user ID, or whatever. And I pass it, the user, okay, I click it. Or I can mask, I run another application over, and I can mask this, okay, the user trust. I can change the values that is shown to the user, and you trust and transfer. So using the own app. So always validate everything, your deep links, parameters, everything that you receive in your intent. Always validate this. This guy here is more trick. When your app has a browser inside, I need, for some reason, has some browser to show some dynamic content or promotion or whatever. But the problem is that when WebView, it's a full browser engine inside your app. And when you run this, when you register an interface, and I can run any JS code, any JavaScript code there. So if I take control of this, and I can do this with freedom, I can replace a URL, or if a deep link, some sites, some apps has, okay, you receive a deep link when you click some shopping sites, I can't mention the name, but you can pass a dynamic URL. And so if I take control of that deep link and I change the value, I will open a URL here, a browser, that I can run anything inside. So, for example, here, this guy, This is a web view. Yeah, didn't help it too much for the screen sharing, but it's a web view. Looks like the whole app. But what can happen here? So before I do this attack, I created this web view. I checked out the permissions. And so, oh, the app has permission for contact, get location, find location, anything else, Bluetooth, whatever. So, read and write files. I can get the package, I can get your location, I can get your full contact list. It depends the permissions that you have in your app. And so I can, yeah, here I will show the logs here. And so I get all the permissions because I have the package and many permissions in this app. Full read and write, network, mobile, everything. And so I get the whole data from the phone. Even the number. I get the telephone number here. It's glad that it's blurred because you show my phone number. But yeah, and I can also run any code. I can run via JavaScript. I can run any native code. I can invoke any framework here. So always, you have a browser, you have a web view. Whitelist what is the URLs that you can open. Validate everything. And when you register your JavaScript interface, you can put a notation of JavaScript method that it's what's the methods that are allowed. Never leave like this, because I can run any JS code. This is more dangerous, but well, when you need to store sensitive data. Okay, I have a login flow and I need to persist this data. Always use like some random token or random boolean that you store. Okay, it's logged or something like this. Don't save tokens or whatever in shared preference, because shared preference is basically plain XML that is saved. And if I have a rooted device, I can just go in the folder and expose that. I can open the preference from any application if I have a rooted device. But with Frida or some ADB commands, I can bypass this also. So here in this case, I have some login, I have some labs, and I will show in both ways with Frida and with this guy. Here. So I expose it because there is a call in your manifest that will show, and it's okay, I have. And I reversed the code and I found some keys. And so I can check the values. And so I have the tokens, I can manipulate this and put back in the app, and I'm logged in, or I'm admin, or I have the full power in the app. Or some tokens that wasn't supposed to be there. So how I suppose always encrypt this? We use it to have encrypted sharing preference, but was using a library from Compose, Jetpack Compose, encryption library, but was sunset by Google. And so the recommendation is use data store with encryption and with Android key store. So a few 2 or 3 meetups ago, Gleb, that we'll talk later, he had a talk about this, and so you can revisit in the story. But he had a talk explaining how to use data store and in the encryption part. Anyway, the same when you are using SQLite or cached files. Via ADB, I can pull these files. I can download the database or the files that it's mentioned in your source code, and I can just read from there. Any session, any cache, anything, the images or whatever is inside. So every time, encrypt sensitive data. Don't store what you don't need. Tokens came from the server, always. I talked about database, but yes, we have SQLite and in mobile apps, and we can have also SQL injection, because many of users don't do parameterized queries that, oh, but I use room. I have the library room. Yes, fine. Room solves so inside the app. But when you expose using a content provider that basically you create an internal endpoint, is raw SQL. So you need to write the whole SQL. And if you don't sanitize the data, the inputs, you can have everything exposed. Let's say that my app has multiple users, or I cached some data that came from the server. Users, oh, I have a leaderboard, and I cache the users' IDs or whatever from other players. And I can do this. Because I didn't sanitize everything, and so here I'm listing all the users that was stored here, because wasn't sanitized there. Again, I use a room, fine, but for content providers, you write basically wrong carries. And so need to sanitize this, check the values, check the inputs that you are having there. I need to speed up. So I was talking a lot about Frida, and so when I mentioned Frida will hook up a process in the device or in the process. There is a Python library that you can do something like this. Let me check if I put here. I can show later the library, but what happened with this Python library, call it input. It will attach a 24 megabyte library, call it gadget, and that will hook up with your process, with your application. So this will run your normal libraries and will run a second library that I can attach any JavaScript. And so I can run any JavaScript in the process. And so I can read everything that is dynamic in your application. So here I'm running my application that it's already infected, attached with the library, the gadget that was. And so I can, with this, bypass SSL pinning, root detection, authentication logic, many stuff. So if you go to the official Frida website, you can check many scripts for specific apps or in the forum or so. Let me show. First I need to forward. So Frida is running in my device, in my computer, and so I'm forward this port to the device port. So now I can, for example, where's in the beginning of the app? Yeah, here's I need to refresh, but what I'm doing here, I run this JavaScript code that now this app, every time that runs, while I'm inside the app. If I had a check, like some payment check, we'll check, okay, it's rooted, this device is rooted. If you are using some libraries to check this security. So here, all the time that you have the check, it will bypass and say, no, the device is not rooted. So I can do whatever because my device is rooted, and so I can explore more data from the user. But also, is it? As I mentioned before, for example, bypass, SSL pinning. And so what is this? I can capture the traffic. Oh, I have a production app. And normally, your production app, you can't inspect the requests. So I'm running here, and I bypass this, I enable the HTTPS, and so I can intercept this in the production app, and I can use Charles, Proxyman, or Burp to capture and inspect the data. Really dangerous. And so before I run it inside the ADB, but here I'm getting everything that is in the shared preference. And every time that something changes, it will update here. If the app change, oh, email, token, or whatever, will always show everything that the user is saving in any shared preference file. So it will keep printing to here, and so it's easy to see how the application is running in the background, what is saving, what is dangerous. So, what this means, and so here there's two pillars that you need to, when you are developing your app, you need to think. You need to have a mindset as an attacker that, remember, your application, your APK is public and readable. You can read anything. Your manifest declare, and it's a blueprint of everything that I can reach. Your local storage is trivially accessible on rooted device, but I can use like Frida to expose everything that you have there. I can use runtime hooks like Frida or other app that do this to bypass your logic, and I can disable or enable features. As a defender, I always have to audit my manifest. Okay, check all your activities. Check your services, broadcasts, everything. What is needed to be exported? What needs to be open to other apps? Validate every input. Validate every intent data that you have. Encrypt everything that needs to be saved locally. As I mentioned, use native libraries to do this. Validate every input. As I mentioned, parameters, web views, whitelist, everything. Even that this whitelist needs to be, came from the server. But when it came from the server, also can be manipulated. So you need to take really care. So test the app the way that an attacker will do. How I can break my app. So the source code of this app, it's here on GitHub. And so you have more how you use Burp and GDX. There are more stuff. And it's not how you break, but how you fix. And so everything is commented here. You have access for everything, how you fix, how you broke. All the demos, there are more stuff here. There's the whole map. And first, thinking about security is understand the architecture of the app. Know your attacker surface. Know how that app works. Think like an attacker, build like a defender. That's it for today. Questions? Sure.
you.